All right, guys. So this morning we're picking back up in our project of building out an application here to handle store stuff. And so yesterday we left things at the fact that we'd done some of the create, read, update, and delete operations for customers. And we were going to have my friend try to do the same operations for store owners. So that would give us the ability to create, read, and update, delete customers and store owners. So looks like we have code for all that. And then we'd started looking a little bit at the main program loop as well. And then, we had pseudocoded out some stuff about the, we pseudocoded some stuff about like the, where'd it go? I know we did it, right? There's create account, and then yeah, and then we started with the login function as well. So for now, let's just comment out the failing part, and we'll go ahead and test the code that you've written for the store owners. So first, I'm just going to go do a whirlwind look through of it, see if anything jumps out at me. And then the other thing that I was going to have us do today was I was going to have us try to make these functions generic, not proper generics, and I'll explain what that means eventually. But basically, I want us to add parameters to the functions that let us, for example, specify which file to open and then what the field names are. Yep. And then we're also going to try to reuse as much shared code as possible, basically, because if we do this right, what we should be able to do is we should be able to use the same functions that we're going to try to make here for customers and store owners, which we've already done. But we should also be able to do the same thing for store products and stores. And I guess that's probably it here, right? All at the same time without having to write even more functions for them. Okay, so that's going to be the plan for today. But before we get there, let's go ahead and look at what you've done here with store owner records. So you started with create, it looks like. Now, this code right here, did you change anything from this code versus what we did up here?
Mostly, I think it was essentially everything that was limited to the customers. Customers. So I changed it to work for store owners only.
Okay, so this had a parameter with customer, right? And if we look down here, so everything is the same. All of these lines are the same from 155 to 161, exactly the same here, right? So it's this line here, 189, that got changed from this line. But other than that, exactly the same. And then the right row is exactly the same as well, right? So once you've been programming a while, this function should jump out at you and scream, I should be a function of my own, right? Because you copied, what, 15, 20 lines, and everything's the same except like one thing, right? That is something just asking to get refactored so that you pass in a parameter for this, and then the function itself gets reused. Does it make sense what I'm saying? Like why we'd want to do that? Like how you, sometimes people will, as I've said before multiple times, there's the people who plan everything out up front, and then there's the people who kind of, code as they go and then refactor. And then there's pros and cons to these approaches. Well, this is us doing the second approach of, okay, we've started doing the things that we want to do. So we've made these functions, and now we're going to do it for another one. But as we get in the process of doing it for another person, we see, hey, a lot of this stuff is really similar. Why don't we try to make a shared function out of it? I will say that the better you get as a programmer, the more of this you're able to just implicitly do. So the people who plan everything out front, well, that is a lot harder when you're kind of inexperienced. The more experience you gain, you won't even write a plan down. You'll just immediately make a shared function because you're like, I'm going to have to do all this stuff every time anyway. So like,
Yeah.
so what I'm saying is the exercise that I had you do here, where you went and you did all the stuff that we'd done for customers, for store owners too. I had you do
Yes.
that mostly because I wanted you to do it, not me. In a
Okay.
production environment, you almost always do the case of a single thing first. So you got to learn how to walk before you can run, right? And
Yeah.
here specifically, when we wrote the functions, it's a big trap to get too focused on making something that is repeatable that you can use for multiple things before you even figure out how to do it for a single thing. You see what I'm saying?
Yes.
So the proper procedure most of the time, and this actually, we do this a lot. We do this a lot in my professional development environment. This is what I advocate for the younger guys on our team to do too. Don't try to do what we're about to do from the very beginning. It might seem really tempting. Like, why don't we jump straight to this? Why don't we jump straight to doing the general case where we pass in parameters to a function and we try to reuse the code like this? Is because it adds complexity. It makes it harder to think about because suddenly you're doing something that's very abstract. Now, I am not of the opinion that you should leave things how we have them here, though, either, because if you do that, then you have a lot of repetitive code in your code base. And so this is bad from a maintenance perspective, because if you ever go change something in this function, now you have to change it a whole bunch of places rather than just changing it in one place. We've talked about this before. So we're getting into some of the design parts of software engineering, but you should always do the non-general case first, at least once, right? I would usually, most experienced developers won't do it more than once. They'll write the function and then they'll figure out how to make it like pass in parameters, right? So they can use it in other ways, but they will still write the function first. Does that make sense?
Yes, it does.
Okay, so we're going to go ahead and we're going to try to build out things that we want to make shared then. So in create, we both use this code block here, where what we're doing is we're finding the table in we're finding the row in the database ID tracking CSV file where we're tracking the max ID of the table that we're working on, and then we're going to increment it by 1, right? So that is what we're doing here. So how about we write a function called increment max ID of specific table. Okay, and what parameter do you think I should take in here?
Customer and store owners.
So this string right here would be the thing that is changing, right?
Yes.
Everything else is the same but that. And what does this string represent? Like, what do you think I should call the variable?
Okay. User.
So what happens if we want to do this for something that's not a user, though, right? Do you think we'd also want to be able to create products or stores?
Oh, yeah, right. That's true.
I mean, I'll give you a hint. We're calling a table name right here, right? So
okay, so table, right?
right, yeah. I mean, sometimes if you have the same conceptual thing and you're using it 2 different methods, it's a good idea. You don't necessarily have to match variable names exactly. This should sound familiar when we talked about variables and scope and stuff. To kind of wave my hand a bit, this is a different variable than when it's used in this function, right? Like, it's in a different scope. These 2 variables don't see each other. They don't conflict with each other because they're running in different environments, basically. But if you match the names, it's easy to think about your application, because then you're like, oh, this thing's a table name. Well, we're using the table name over here, right? So watch this. We're going to, although actually you'll see a problem with what we just did in a second here. So the first thing we're going to do is, why doesn't it like this? Let me make that a lot smaller. Not sure why it doesn't. Oh, we have, oh, I know why. I'm sorry, I'm being silly. It's because we have the syntax error up here because we hadn't pasted that yet. And then that'll go away.
Okay.
All right, so this will have to return something because you see how we're using a new ID down here, and we need to get the value of the new ID for us to put it in the new data record. So this function here, what do we want this function to return?
It should return the table name, whether we're dealing with customers or store owners. Okay, max ID, right?
Okay, so you say max ID.
Yes.
But so what information, now that we removed this code here, what information do we no longer have?
The new ID.
Here, I'll hover over this message, right? It says undefined name, new ID. So what we need to do is we need to do new ID, and then what should this be set equal to?
Max ID.
Okay. Well, you said max ID. What is, you mean like, be specific.
The incremented ID, of course, the like new ID plus one, something like that.
Tell me what to type here.
Okay.
So we just removed all this code and we put it in a separate function. So what should we set this variable equal to? I have you a hint. It should have something to do with the code we just moved, right?
This function should return something, right? And
or do you want to do that first?
This,
we can do
that's
that
what
first.
I was thinking.
I mean, it's not going to work until we do it both places anyway. But
okay, I was thinking that you would set the new ID to what it returns. Am I wrong about that?
No, that's correct. So the point is, we're going to call the function here, right? That's all I wanted you to say.
Okay. I was actually quite confused about that earlier. I was thinking about calling the function in another function I was writing, the login function I was writing, and I didn't really know how I was supposed to do that. So I didn't know you could do this.
Well, so this is pretty essential stuff, right? So what do we want to pass in? Okay, so actually, let me explain an issue here before we get too much farther. So you see how we have a variable here called table name, and then we are also using a variable here called table name, right?
Yes.
What's the problem with this? Like if we do this, like you see the problem here is that it's going to think that these are
same thing,
right? So so that we don't have that problem here, what I'm going to do, I'm going to actually rename this variable here. So we're going to rename so that it's the row table name, and then this one will just be the normal table name. So that's less ambiguous, right? Row table name is the table name coming from the row, right? And if row table name is equal to how about we, to make it even more precise, how about we say this one is input table name.
Okay.
If row table name is equal to input table name, right? And now we're going to increment and we're going to grab the max ID only for the row that we're interested in. Or sorry, and the row that we're interested in is going to be the one that matches the name of the table that we're passing in. Okay, so now we need to replace this with a call that will make this work. So previously we had just copied the code that had the word customers hard coded there. So what should we call this function with?
This function with the name of function, right? Increment max ID.
I meant like what variable do we pass into it when we're calling it? Because this function takes in.
Okay, if we're calling it here, If we're calling it here, we would call it with input customers, right?
Customers. Yep. Okay, so let's walk through what we've done. So we took out all this code here that previously had the word customers hard coded here and was going to go and increment the max ID of the customers row in the database ID tracking CSV file, right? And what we've done now is we took all that code, we put it in a function. We're now passing a variable called input table name. And that's what we're checking against for the table name that we want to increment the max ID for. And then we're going to return the new ID that has been incremented. And then this will be a number because when we do math on it, we're incrementing it as an integer. Okay, so we're going to return the new ID. And then once we've got the new ID, see how we've made a function call. Now we use that new ID to build our new customer data. And so this function now, way shorter, right? And none of this stuff is really all that related to the customer stuff. And you can see if we choose our variable names well, and we choose our function names well, this line 173 here, it should tell you exactly what we're doing. Increment max ID of specific table. What table are we incrementing the ID of? Customers, right?
Customers, yeah.
So when you read this line of code, at least I think we picked a pretty decent name. It should tell you, hey, we're going to increment the max ID of the specific table, and then we're going to get the new ID from whatever was incremented, right? And then we're going to assign it equal to that value. But like that's pretty descriptive, right? So you should know when this line executes, even without knowing anything about how this function works, you should know what it's doing, right? And that is exactly what you want to shoot for when you build good code, is you want everything to be self-documenting. You don't want to have to write it out in words, because once people become more experienced developers, they'll be able to look at this function and be, oh, okay, that's what it's doing. And, you know, like that sort of clean self-documenting code, regardless of what programming language you're in, that's always what you want to shoot for. Okay, so now
it's fine to
go ahead.
I was going to ask if it's fine to actually use long names like that. That's question one.
Yep.
Okay.
It's a trap to get, because the compiler does not care. Okay. So you might think, oh, long names would make it slow. No, it won't. These things, I don't want to get too technical, but these code is for us. Okay. What the computer runs, this maybe is a disadvantage of not having some of the theoretical background that they like pour into you in programming classes in college. What you see on the screen isn't even close to what the computer actually runs. There's something called a compiler. For Python, Python's not a compiled language, it's an interpreted language. What that means is that, you know, I'm not even going to go there. But the computer turns everything you see on the screen into ones and zeros. That's what's actually executing on the CPU. But that process there, the computer does not care what we call the function, what we call the variables. In fact, there is a concept called code obfuscation. So JavaScript is public because it runs in the browser. So you might, if you don't want someone to be able to copy your JavaScript library, you can run it through a code obfuscator, which will rename the variables and the functions to make it hard to understand. So if you have, see? So this is the code that we started with. We have a function called hi that logs hello world to the console, right? It's a basic hello world function. And then when we obfuscate the code and look at the output, do you know what any of this means?
No.
Right, exactly. I mean, this is a hex code right there. I know that, right? Oh, look, a function. We're calling a function. But this sort of thing right here, I mean, I'm not saying computers run this, because this is very contrived. But I'm saying that this code right here is functionally equivalent to this. The computer thinks they're the same thing, because the computer doesn't care about variable names. That's what I'm getting at.
I see.
So Yeah, good question though. No, and in fact, I'm kind of opinionated here. There are some, it's called code style, in terms of how you name things. And you might want to be consistent, because if you're consistent, it kind of helps people learn your code base and stuff. But I favor names that are very descriptive, to the point that maybe they do get a little bit long. I mean, like, okay, there's like common sense bounds here. Like, for example, let's say we kept going on this name, right? This name, I don't think you can make it too much shorter than this. You might be able to get rid of the word specific, right? Increment max ID of table. But the problem with that is that, well, then is it always the same table? If you say specific, then it's like, oh, okay, it's going to be the one they pass in, right? But you could, if you kept going, you could do something like by opening CSV file and writing back. Okay, this is too long. And also, it doesn't give you any helpful information, right? Like the information I just added there. Why does the user care that we're opening a CSV file and writing back to it, right? That has nothing to do with how they call and use the function.
Yeah,
Okay, I don't think I'm going to spend too much more time on this, because I don't want us to get too sidetracked, but it's a good question. Try to keep variable names as short as possible while conveying the maximum amount of information, right?
Okay. So my second question is, I did mention it earlier. You can actually call a function by setting it equal to setting to a variable. I didn't know you could do that.
So this is
The only way to do so is
pretty important stuff. You don't actually have to even set it equal to a variable to call it. Functions have argument lists, right? So even functions that don't have arguments, you will call with an opening parentheses and a closing parentheses. This is out familiar.
Yeah.
Okay. So if I have a function, where am I here? Let's say I have a function that gets me a number. Okay. I would still call the function like this: get number, open parentheses, close parentheses. And as long as you can see this function, that means it's in the same file. The function is defined in the same file. That's all you have to do for it. Now, if what's a good example? If I want to do something like get whether or not a number is odd, right? So this would either be true or false. I would need to pass in a number to check, right? So this might be what the function would look like. And then to call the function, rather than the variable, I would pass in an actual number, right? So we would expect this call right here to return true, because 5 is odd, 6 is even, 7 is odd, right? So is there anything? So you see how down here, CSV.writer.
Yes.
Are we calling a function in this line of code?
I think so.
It's not a trick question. So we just said
no. Judging from what you've said right now, we are. I just never did. Yeah.
Okay. So the thing to follow here is parentheses, right?
Yeah.
So
okay.
If you have a word and then you have parentheses and something written after the word, you're calling a function. And what you're doing is you're taking this information and you're basically handing it to this function, right? This is called the argument list. That's the jargon that people use. You pass the argument list to the function, and the function will take whatever the arguments are, or the parameters. Technically, they can be a little bit distinct, but let's not worry about it. You might hear people call them both things, or the function variables, what you're passing into the function, and then they can use those in the function, just like we're using our input table name up here, right?
Okay.
So that's how you pass data. Passing data is the important bit. So we're taking information from this function here, customers, and then we're passing it over to this one. these are the interfaces. What does the function take in and what does it spit out, right? So those are the important questions to always ask when you have a function. What do you give it when it comes in and what does it spit out? Now things get a little bit more complicated if you have a function that's changing a data thing that's like shared. We'll get to that when we get to object-oriented programming, because suddenly it doesn't just become about what your function takes in and what it spits out, but it also becomes about what it did inside the function. Because if it changes something that is like shared, then something else might have changed in a way that's not quite so obvious from inputs and outputs. It's called changing state, but we're not there yet. So for now, what you have to worry about is what do functions take in and what do they spit out, right? Now, if you don't assign a function to anything, calling this will actually work just fine. If we increment the max ID of the specific table, but we don't set this equal to anything, it will still increment the ID of the specific table. This call still happens. It's going to return new ID, but it's going to be like, well, okay, I'm returning new ID, but I'm not setting anything equal to the new ID. That's why we need the variable assignment there. But variable assignment is completely separate from the function calling process.
Yeah.
So when this code executes,
when
this code executes, something that confuses people is they say humans read left to right, right? So we would say new ID equals. Conceptually, the first thing in this line is new ID. To the compiler, for assignment statements, the computer actually executes what's on this side before it does the assignment. So it takes this variable and sticks whatever comes back from over here into this variable. But it ignores this part of the line completely until this part of the line finishes executing. So this isn't to say that computers read right to left, because they don't. But programming languages execute in the order that like makes sense, right? So you go from this line to this line. First, you have to get the value of whatever this function is, and then you set, the value of whatever this function returns, and then you set this variable equal to that value. That's how the computer looks at it.
Okay. So if you were to just call this function without setting it to a variable, would this line customer data still execute, since it doesn't have there's no variable called new ID?
No, you would get error here. It would not work. Because
so
we're
that's
using
why
the
we
variable.
set it to.
We're using the variable, right? And that's why we need the variable, right? Because we're using it here.
Okay. All right.
So let me emphasize again how important this is. Restructuring your code to use helper functions is what they're typically called. Helper functions, auxiliary functions, these things that let you create a level of abstraction, right? And what I mean by that is we're calling a function right here that says, I'm going to implement the max ID, or I'm going to increment the max ID of the specific table. And then you're passing a table name. You don't care how this function does it. You really don't. You may have heard of the programming concept called encapsulation, right? This is the idea that functions are black boxes to us. They take things in and they spit things out, but we don't need to know about what happens inside the box. We don't need to know what the magic is, right? Very, 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 very important concept in computer science, because it lets you use other people's libraries and not understand them. You just need to know, to be able to use a bit of code, you need to know about what it takes in and what it spits out. You don't need to know anything else about the code. Yeah, you better get comfortable with that, because you do an awful lot of this as a programmer, is copying or using someone else's library that say they've done something, and you want to do that. I have
no idea how it was done.
And why would you write something if someone else has already done it, right? You just need to know how to interface with the thing that they've already done. And in big applications where the scale gets really huge, so for example, my coworkers and I were curious the other week. We wanted to know how big our application was. And I mean, it was hundreds of thousands of lines of code. Okay. Now, of course, a lot of that's boilerplate. Like there's some scaffolding that has to go up when you create files of a certain type, blah, blah, blah. So in terms of like actual like logic lines of code, like things that we'd have to sit there and look at and figure out what it's doing, a lot less than that. But I mean, still, huge project, right? I mean, of course, there's a team of me and like, more than 10 other people working on this project. And if each of us work, 8 hours a day, 5 days a week for years, of course, the project's going to be big, right?
Yeah.
But, within that project, anytime someone has done something, you want to reuse what's already there, except maybe
Yeah.
you don't want to understand the specifics of how they did something, right? To you,
Mhm.
you should try as much as, I'm not saying that you shouldn't try to understand stuff, right? But
Yeah.
when you're
Yeah.
using a library, what you should get through your head is that you shouldn't be ashamed of only understanding what goes into a function and what comes out of it, because unless you really need to know the other stuff, you don't care, right? Because
Yeah.
it doesn't functionally help you write better code. As long as you properly understand the inputs and the outputs and what the thing's supposed to do, you can just call the function happily and not worry about anything else.
Yeah.
Yep.
I feel like it's a little like using a hammer or a screwdriver or a wrench. You might not know how they're built or what kind of they're made of, but you do know what to do with them. So
yeah, that's a reasonably good analogy. Black box is typically the analogy used for functions, right? You put something in the box, something comes out of the box, but you don't know what's in, you don't actually know like the internal mechanism in the box. That's in all the programming textbooks, that's the analogy, the black box analogy. But calling functions, very important. So, I will say that getting comfortable doing it is going to be really important for us moving forward, because, we're going to be writing our own functions when we do object-oriented programming. We have classes can have functions, and you need to understand, how they're called and executed and when you'd want to call them and things like that. But I mean, so yes, at a high level, it is perfectly fine for us to do what we're doing, making a new function and then calling it. Okay, so all of that work that we've done here so far was just getting us the ability. So now we've made this function a little more general, right? We made a function here, we parameterized it so that we're not hard coding anything in the function anymore, and now we're passing a string. So this made the create customer record a lot shorter. Now let's do the same thing, but for the store owner record. So right here, we have the table name store owners. Watch this. We're going to copy this. Let me do it this way first. We're going to copy this call here where we're getting the new ID, right? We're going to stick that right here. And then rather than customers, we're going to do the same thing, but for store owners. And that took all of what, 10 seconds, right?
Yeah.
Okay.
That's really cool.
Yep. Okay. So now we've used the same function in two different places, but it's doing the same thing. Well, it's not doing quite the same thing. It's doing a little bit of a different thing because this one's only doing it for the customers row, and this one's doing it for the store owners row in the, the CSV file tracking max IDs. So does it make sense what we just did there and why we can use the same thing in two different places to do very similar operations?
Yeah, it makes perfect sense. I understand.
Okay, now we're even going to go a level deeper. Okay, so you see these two functions here?
I was going to ask that, but I was trying to answer it for myself. They're very similar. Is it possible to actually make them one function that you can call for customers and another and the same for store owners with some differences? It looks impossible. I don't know.
Okay. So some things will be easy, right? Like let's find differences. This and this are different, right? But the call to this function is the same. The name of the CSV file is different. That's actually also very easy because this is just a string, right?
Okay.
Don't care about this. We don't care about this, right?
Yeah.
Okay. So right here, we have three things. We have name, password, assets, liabilities. And you see how we're going in order. We're adding all of those things to a list, right?
Yeah.
And we're sticking new ID on the front. Here we have name, password, cache. That's different, right? But
Yeah.
it's different in a way that probably doesn't look quite so easy to
Yeah.
handle, right?
Yeah, that's actually where I was worried.
Okay, so let's do something that will handle all the rest. You know what, let's just call it create. So let's do something that for now, let's base it off of this customers one. So we're gonna add some parameters here. So our create method already had name, password, assets, liabilities, right? But now we're gonna, how about we add something for, let's call it table name like we did before, and then CSV. So you see how we just added two parameters here.
Yeah. And we can also add cache then, right?
So,
Yeah.
oops, oh, I actually copied the wrong. Yeah, I copied the wrong set of arguments because the liability is just from the other one.
Okay. Okay.
We're doing it with the example of customers here first. Okay.
Okay.
So to make this general, so we added a parameter called table name. Let me start out by giving an example of how we call this, right? So here was our old create customer record, right? And now we're going to call this like this. These are kind of what these things represent here. And then, well, if I could. So tracking so far?
Yeah, I am. I am.
Okay. So, you know what? Let's be smart too. Let's see. You see how I've named all of these files with underscores, except for that one. Shame on me, wasn't consistent. Now we're naming all the files with underscores, right?
Okay. Past examples too.
Well, that is a Python file. That's not a CSV file, but just for consistency, we can do it. But so the CSV files represent our data, right?
Yes.
We're naming all of these things with underscores. And then here, we have everything has underscores, right? So you see how in our main code here, do you think we really need two separate input variables for customers and customers.csv? What's different between these two things here?
Just the CSV.
Okay, but if we were to do this for store owners, right? You see how this is store underscore owners, and then this is store underscore owners.csv. What's different between those two?
CSV too.
Right. So we really probably don't need two variables here, right?
Okay.
Do you see why? Because if we have the table name, we just stick CSV on the end of it, and that's what we put right here.
Yeah.
Right.
Yeah.
Okay.
Yeah.
So we can get rid of that. Okay. So now let's try to write the function so that we can call it like this. So given that we have customers, right? In fact, it's nice it even highlights it for us, right? So if we say that we're customers, when we call the function here, we're sticking customers in the first spot. Which one of these inputs to the function does customers correspond to?
Table name.
Okay. So everywhere we see customers here, what should we switch it out with?
Table names. Table
Okay.
names.
So
Table underscore name.
table name, right? Well, table name. And then here as well. Now this one is going to be trickier because we want to add, let's put parentheses to make it clear what we're grouping here. So does that make sense? Do you remember what the plus operator does with strings?
Yeah, it concatenates the string.
Concatenates the strings, right? So this should take, we give this customers, it should take customers and then add CSV to the end. Customers.csv,
Yeah.
right? We do the same thing with store runners. Does everything that we've done so far make sense, right?
Yeah, it makes
so
sense.
This is already better, but unfortunately, this still isn't truly general because we still only have name, password, and cache. Well, the problem is store owners have password, assets, and liabilities, right? So one option for this is that, well, both kinds of people have names and passwords, right? So maybe we just make a longer list of these things, and then, so if we pass a whole bunch of stuff, the problem is, well, still, which ones do we put in the data then, right? Like, how do you determine that inside the function? So what we really want to do is figure out how is this data right here. So that's really passing stuff, never the best idea, right? What we really want to do is pass just the information that is going to be different. That's the only thing we want to pass, right? Okay, so let's compare the data.
Okay.
How is this data similar than this data? And let me be real clear. We didn't pick the best example here, because if I were to pick something like, let me go find one. See, customer, I purposely had you do a similar one with similar fields, but most of the other things don't have fields so similar, right? Let's compare this. Let's compare this to product, okay? Let's let this be our comparison because we want to use the same create method for everything, right? Okay, so right now, let's have us compare, just to be parallel, this would be what the data call would look like for products here. Let's compare this list to this list. So what's the same?
Okay. They both have new ID.
Okay, they both have new ID, right?
They both have name.
Mm-hmm.
And that's about it.
Okay. Now, to be very precise here, they may not necessarily have name, right? So far in our design of our data, we actually did make everything have name. And it's not that atypical for things to have both ID and name. Like these are two fields that are very, very, very common when you store data. Because you need to know what the database thinks it is. And the database tracks stuff by IDs. It doesn't care about names. But then you as a human want to know what it is. Because like an integer ID of like 7 doesn't mean much to you, right? But if 7 represents, if 7 represents Alice Carter's record in the database, and if you have the name on the row be Alice Carter, then oh, so the database thinks this is ID 7. Database doesn't care about the name, but to us as humans, we say, oh, this is Alice Carter's record in the database, right? So ID and name, super, super, super common, right? However, for the sake of argument, let's say that we had something here where we didn't have a name for whatever reason, right? Name is not implicitly something that we can count on being there, right? It happens to be in all of our cases, but we want to write robust code, but ID will always be there, no matter which one it is, because that's how we're tracking our data, right? So in terms of our comparison, we said here, for the time being, ID and name are both there, but really we want to code it to only rely on ID being there because sometimes name wouldn't have to be there, right? Okay. So we have, we have two lists. We have list 1 has this, right? New ID, and then has some other stuff, right? And then list 2 also has, and then some other stuff as well. So this is the similarity, right? Okay. So you see how the only thing that's identical is that both of these things are lists, and both of them, the first element in the list is new ID, right?
Yeah.
So I'm going to do this just because I don't have too much time, and I kind of want us to get through with this point here. So this might blow your mind a little bit, but name, password, cache. These are things that we have in the customer record one here, right? So right now, these things are their own values, and then we're putting them in a list like this, right? So let me Google something, and let's see if this helps. Let me see if you can guess what I'm about to do. So how to add something as
Cell and list.
this, right? List
Yes.
insert. We're going to insert something at the first position of a list. Okay.
Okay.
So let me see if you can tell me if you understand why I would do what I'm about to do here. So first, I'm going to take this and I'm going to rename this from data to, or from customer data to just be data generally. Okay. Okay.
Yeah.
And then I'm going to have something called fields here. And I'm going to say fields.
Okay. I think I get it.
Insert. Okay, and now it's going to complain fields doesn't exist, right? But what happens if we replace all this?
Yeah.
Fields.
Oh. Yeah. That's so cool.
Clever, huh? Right? And so now let's see if we can come up. Let's see if we can come up with how we call this. Let me give you a hint. I add 2 characters to this line. Actually, I need to add more. I lied, because previously we were converting this to a string in there. So we actually need to make it a string up front. But this is how we call this function here.
Yeah, that's true. That's how we call. Right. Oh, cool. When it's done, it really looks so simple. It's like you're stupid for nothing.
It's actually it's a kind of a good sanity check for yourself.
Yeah.
A lot of the time, if you are writing 50 lines of code and it's ugly and really complicated, you probably did something wrong, right?
Yeah.
I'm not saying that code will never be like that. There's some times where you just can't do something very simply. But this, what I'm showing you right here, this is one of the powerful things about Python. Python doesn't care about what data types are in this list. You can pass whatever you want. It makes it really easy to write clean functions like this, that you can pass information like this, and it will happily just let you pass whatever you want in this list variable. And the way I like to explain this is Python gives you more than enough rope to hang yourself, right? It lets you do some really cool, powerful things like this, where we don't care what's in the fields row. We're just always going to stick the new ID as the first thing in it, right? And so it lets you not care about fields. You can pass whatever you want in fields, as long as well, actually, it doesn't even have to be a list. You could pass something that's not a list here, and then this call just fails, because then at runtime, it'll be like, hey, this isn't a list. I can't insert into it. Then it'll yell at you when your application is running. So with great power comes great responsibility, is what I'm saying. Many languages like C#, you could not write a function like we just wrote. you couldn't do this whole fields thing. Or actually, you probably still could, but you would have to enforce with types that fields is a list of strings. Okay.
Okay.
In Python, you just don't have to care about it. You just fields is a list. I just don't need to write it. I know it's a list. When I call it, I'll call it like a list, right? Okay, so that is the create customer record call. And this is going to be, you tell me, what do I need to change here to make this one work? So let me
just you need to add store owners here.
Okay. Store owner, right?
Yeah, then put everything in a list after that.
Okay, and how about the numbers?
Yeah, that the quotes to make them strings.
Because when we write everything to the CSV file, we're writing them all as strings.
Strings, yes.
Does this make sense?
Makes a lot of sense.
Okay.
Yeah.
So once you've seen it, like you said, it doesn't seem so bad, right? And so you remember how we had those two functions coming into today. We had the two create functions, and they were both long because they had this business. And then now in our code, we could even get rid of these. I'll comment them out for now, but we don't even need to use those anymore because, or well, actually, sorry, no, we don't need to use these two anymore because we can leave these things as a comment above the function. This is how you call this one. This is how you deal with it. And this function still calls the increment max ID of specific table like we wrote above, right? It's the first thing. Why did
I think it's the second one. That one with the Manson thing. No, the third one then. That one.
Third one. It's because I had that.
Yes, that's it.
That was confusing me. Yeah. Here we go. I wanted to group these two together and then get rid of the other ones.
Yeah.
Okay. There we go. Yep. All right. That's where I go. I gotta go to work. Here we have a big meeting this morning, so I can't be late. But your job now, before we go on and do more stuff with the main program loop, I would like for you to try. I know that this was probably a little bit more mind-bending than just simply writing functions. But now that you have two functions we just did that for create, right?
Yeah.
You see how we added some parameters, and then anywhere, what we did was we went through and we looked anywhere our code was different, right? What did we change? Like I said, once you get more experienced as a programmer, you probably won't write it twice and then do it. You'll probably write it once and then do it, right? So it's actually very helpful for the little beginning when you're getting better at programming to actually write it twice, because then you just look at the code and you look at where things are different, right? And then you make that a variable. Once you're doing it, once you get better, once you have more experience, you'll be able to just look at code the first time and figure out what would need to change if I were to write this again, right? That jump takes a little bit of experience, though. You probably won't be able to do it right from the get-go. Okay. But regardless, you have more functions here. If you get really stuck, rather than banging your head against the wall for a very long time, maybe it's better to not. Let me give you a hint, though. So you see the curly braces here?
Yeah.
What data type is that in Python?
That's a dictionary.
That's a dictionary, right? Okay, so you're going to need to try to figure out a way to build this dictionary dynamically, right? Not hard coding all these things, but build the dictionary based on the data in the row. So you're going to need a for loop, and you're going to need this variable here called field names. And this variable this variable will be really easy to pass, right? Like we can pass that in.
Okay. Okay. That's
So
going to be
that's my hint, but see if you can figure out how to make read and update and delete also generic.
Okay. Okay. Okay.
Okay, so we're ignoring ID here for update, and we will continue to ignore ID across all fields. So you won't have to worry about that either. Well, I'm going to sign off here. And so I hope this has gotten you a little bit excited, right? This is kind of the thing that you could do when you're programming. Once you realize how you can pull code out, make it more abstract, suddenly the power that you have expands by a lot, right?
Yeah.
Okay, well, that's where we'll stop for today, and we'll see how far we get tomorrow then.